Welcome to Physics and Rapid YouTube channel. In today's video, I'm here with a new concept called JJ coupling, that is under equivalent case. I'm going to solve the question called P square. Okay. Yes, this is a very important concept, or you can call it as a very important question under case examination under physical science question paper. Okay. Yes, let us start with the question, that is JJ coupling equivalent case. We have the question, that is P square. Now, how to start with the question? In the previous video, in the last three videos, I have been solving about the LS coupling and equivalent case and the non-equivalent case under LS coupling, and JJ coupling equivalent case. Today I am going to solve non-equivalent case. I have solved in the previous session itself. You can go and watch in the playlist. Yes. Now we have a problem called P square. Now I need to find the electronic configuration or the energy levels, how it is accommodating, and we need to find the combinations as well, right? Now how to start? We will start with the P square, and we need to find the value of L1 L2 values, and we need to find the values of S1 S2. Yes, and we have here L1 and L2 same, because P square is nothing but PP. What I said, if L takes the value 0, then we call it as a s orbital, and L takes the value 1, we will call it as a p, and L takes the value 2, we will call it as d, and if L takes the value 3, we will call it as f, so on, right? Now L, which is equal to 1, that is for p. So p we have, and L1 value will be 1, and p, again we have a p2 and L2, that is a orbital angular momentum. L2 will also take the value again 1, and for S1, for a single electron, it will be half, and S2 will be half. Yes, now this step is clear to you people. And now we need to find the value of a J1. How to find the value of a J1 or the J? This is J value is how to find inside the magnitude L minus S to L plus S. This is the general formula, right? Now we have the L1 S1 and L2 L1 S1 and L2 S2. Substitute the values, you will get the respective J1 and the J2. So for J1, we have L minus S. L minus S means 1 minus half to 1 plus half. 1 minus half means how much? Magnitude of 1 minus half, no negative values, it will be always positive. 1 minus of, that's why we are going to write the inside the magnitude, that is 1 minus half to 1 plus half. So the J1 values we are getting here, 1 minus half is half, 1 plus half is 3 by 2. Okay, and we have a one more term, that is a J2, that is a total angular momentum we need to find. We have again we have the same values, that is half and 1 respectively, that is S2 and L2. Again the same thing, it is 1 minus half according to the general formula to 1 plus half, right? 1 minus half to 1 plus half is J2, which is equal to 1 minus half is half to 1 plus half is 3 by 2. Now what we need to do in the next step, similar to the JJ coupling for the non-equivalent case that I've told you in the previous session or the previous video, the same way we are doing. Only here the splitting of the energy levels is quite different, and we need to take the consideration of LS coupling. Okay, so here we have a J1 values to be half and 3 by 2, and here J2 values to be half and 3 by 2 again. Now we want the combination. For writing the combination, what you will do? So first take the combination of half and half, then take the combination of half and 3 by 2, then 3 by 2 and half, 3 by 2 and 3 by 2. Like that we will get 4 combinations. So the combinations for J are, it is 1 by 2, 1 by 2, and we have 1 by 2, 3 by 2, and one more combination is 3 by 2, 1 by 2, and one more combination is 3 by 2 and 3 by 2, and these are the 4 set of combinations. under JJ coupling for the equivalent case. The question may arise from here itself. What are the combinations of JJ coupling if respective questions for the respective questions. Till here everyone here clear? Yes. Now what we need to do, we need to write the electronic configuration of the energy levels in terms of a term symbol. Okay, or a term symbols, or with the help of a term symbols we are going to represent the combination to the respective energy levels. Okay, yes. Now we will start writing in the next slide. And again, I'm going to write in the slide the combinations. Yes. What are the combinations we are having? That is 1 by 2, 1 by 2, 1 by 2, 3 by 2, and 3 by 2, 1 by 2, and 3 by 2, and 3 by 2. Right? Now, we need to find the j values of these combinations, right? And we are having the j1, and let us consider this is j1, and this is a term from j2, and this is a term from j1, and this is a term from j2. This is j1, and this is j2, and this is j1, and this is j2. Now, I want the values of j. So, if I want the values of j, it is again the magnitude of j1 minus j2 to j1 plus j2, right? Now it is j1 minus j2 to j1 plus j2, will get the values of j. So j1 minus j2 is here half and half, so magnitude of half and half is 0, to half plus half is 1. So we are having the values to be 0 and 1, but I'll say this is wrong. This is wrong. Why it is wrong means, under a equivalent case, if we are having the j1 which is equal to j2, then the series of the values of j as follows here. So the j value will be 2j minus 1 and 2j minus 3, 2j minus 5, like so on. So here we are having the well, and it will not have the not allow negative values. Okay, yes. And these are the set of rules under equivalent case. And non-equivalent case also we were having the combination 3 by 2, 3 by 2, but we did the same way. For the equivalent case we are doing this way. Okay, it is 2j minus 1, 2j minus 3, and 2j minus 5. Okay, and here the j value was what? So we will apply here the j1 and the j2 value is one and the same, that is half. So 2 into 1 by 2 will be 2, 2 get cancelled. 1 minus 1 is how much? 1 minus 1 is 0. So 0 will be the right answer. And for the second and j, we are having a two different values. So it is magnitude of 1 by 2 minus 3 by 2 to 1 by 2 plus 3 by 2. Okay. So 1 by 2 minus 3 by 2 is 2 by 2. 2 by 2 it is again 1. 1 2, here it will be 4 by 2. 4 by 2 means 2 ones are 2 twos are 1 2 2. We are having the values 1 and 2. And again the next is also 3 by 2 and 1 by 2. We will get the same solution. It is 1 and 2. And we are having the last again the same j values, that is 3 by 2. If I substitute here, what I'll get, j which is equal to 2 times of j is what here, 3 by 2 minus 1. 2 2 get cancelled, 3 minus 1 we are having a 2. And the next term is 2j minus 3, that is 2j minus 3 is 2 times of 3 by 2 minus 3. 3 minus 3 is 0. So we are what are the values? We are having the j values to be 2 and 0. Now I'm going to write to a side what are the j values. J which is equal to 0 for the first combination, j which is equal to 1 and 2 for the second and the third combination, and j which is equal to 2 0 for the fourth combination. Okay, these are the j values we are getting. This is for the second and third combination. The j value we are getting 1 and 2 for the second as well as for the third combination. Now our task is to write the energy levels. Now we shall write the energy levels with respect to the LS coupling of a equivalent case, that is P square. Now what we have here, we have the p square, right? And how we have drawn for the ls coupling, I'm going to draw the same way. Okay, yes. And here p square we have, lower the value of s we will accommodate the higher energy level, and the lower the value of l will accommodate the higher energy level. And p square, it is a half filled state, it is a half filled case. For half filled case, lower value of j, lower energy level, lower j, lower energy level. Okay, and this is how the energy level is split. And we'll get the l value to be, lower the value of j will accommodate the higher energy level, and here the s value will be 0, and here we are having the l value to be what, 0, and here we are having the l value to be 2. Okay, now what are the term symbols? At the first we have 1s0, and the second l which is equal to 2, we have 1d2. Okay, you can cross check my previous videos, I have clearly done there. And the next we have three terms we will be having, but according to the jj coupling, we are going to split into 2 and 1. How, you will see. Here we have L values to be 1. Here the S values to be what? For both it is S values or 1. Here also S value is 1. Here also S value is 1, and it is 1 and the same. I'm going to split because for the JJ coupling. Okay. And here the L value will be what? 1. So what is the L value as 1 means? It is the P. Okay. So L value as 1 means we will get the L to be P. So here we are having 3P 2, and next will be 3p1, and the final will be 3p0. These are the term symbols according to the ls coupling. And the combinations we have here, what are the combinations we are having? Go to the previous slides. We are having half, half, 1 by 2, 3 by 2, 3 by 2, 1 by 2, 3 by 2, and 3 by 2. Respective j values is 0, 1 by 2, and 2, 0. Right. Now j values, we are having the j values. Let me write down here. What we have here, j is what? J is here 0, and here j is 2, and here again j is 2, and again here j is 1, and again here j is 0. Right, these are the values we are having. Now for 3 by 2 and 3 by 2, what are the values of j from the previous slide? 3 by 2 and 3 by 2, we are having the j values to be what? 2 and 0. So this will take the value, this level will take the value 3 by 2 and 3 by 2. The same way, we are having j value to be 2 and j value will be 1. For 1 and 2, what are the values we have? For 1 and 2 j values, we have the combinations, that is 1 by 2 and 3 by 2. And remaining is last, that is j value which is equal to 0. And we have the combinations to be half and half. I hope it is very clear to you people, the electronic configuration, how I have split with respect to the what ls coupling. And I hope everyone understood this concept very clearly. From this energy level diagram only they can arise the question, that is which is the least energy level and which is the highest energy levels, and what are the combinations, and we have how many set of combinations, like that they may ask. And which is the first combination, and which is the ground state combination, and which is the highest state combination, like that they may arise the question. And we have one more case. If we take p4, what will be the solution? That also we will say. If we consider a p4, a p4 is, according to the Pauli's exclusion principle, p electron can accommodate 6 electrons, right? Here how many electrons we have? Here we have a 4 electrons. So we will accommodate like this. Okay, this is completely filled and both are unfilled, unfilled or a unpaired electron you can call it as. Here the case for more than half filled case, what will happen? For more than half filled case, here I said the rule to be lower the J and lower the energy level for the half filled case. For completely filled case, for completely filled case, lower J, they will get higher energy level. They accommodate the higher energy level. That you must be very clearer. Okay, higher energy level. It will accommodate the higher energy level means what it will change, instead of here 3p2, we will get here 3p0. Okay, and 3p1 remains same. Instead of here 3p0, we will get here 3p2. Okay, only these two things changes and everything remains as it is, and the configuration everything remains as it is. Instead of here 3p2, we will get 3p0, and instead of 3p0, we will get 3p2. Why? Because of this rule. Okay, I hope everyone is clear with this concept. In the next video, I'll be coming with all 4 topics. What are the previous year question papers, questions from a KSET as well as CSIR net I am going to solve in the next video. Thank you for watching, and for more videos you can visit my channel, that is Physics Unwrapped.